So now we're going to talk about exponential and radical form. We're going to go from the radical form to also exponents. Okay. If x is a real number and n is a positive integer, then if I have something like x to the power of a fraction, okay, now all of a sudden, until now, we've been dealing with x to the power of 2, 3, negative 4. They've been integers. But now if I have x to the power of a fraction, I can write it as a root, okay? And how that works is the denominator becomes the index, and this becomes an exponent here, okay? So this is called exponential form, this is called radical form. So for example, if I have the square root of x, well, if I have a square root, there is a hidden 2 in here. I can write that as x to the power of 1 over 2. Okay? If I have the cube root of x, it'll be x to the power of what? Okay? All right, so let's do these. This is an exponential form. We should be able to convert to radical form. So this, remember, becomes the index. So it'll be the 5th root of a. Here, c to the power of what? Mm-hmm.
If it was c squared, would that be...
Like if it was c cubed. Yeah. Yeah. Okay, so let's talk about rational exponents. Now, what if you have, like Sydney said, what if you have not 1 over something, but x over y? In that case, again, like I said before, the denominator becomes the index, the numerator becomes the power. And you can write it in 2 different ways, okay? So let's take a look at this one. This index will become the denominator. This will become the numerator. So this will be c to the power of negative 5 over 3. Okay? What about this one? Yeah.
So do they both negative or
They gotta be both negative because they'll cancel out. Yeah. You'll never be given that way because, you know? Okay. Yeah.
Wait, could you change that into like 1 over c power 5 over 3?
No. Oh, yes. Sorry. Yes, you can. But right now we're just rewriting it in this form.
If the fraction isn't simplified or...
Yes. Okay, so this one will be 4th root of c to the 7, or, I'm sorry, d, or equally correct, you can write it as 4th root of d to the power of 7. That exponent can freely move in and out of the radical. And how do you know which one is better? That kind of like, it depends on the problem you have at hand. Sometimes it's better to write it that way, sometimes the other way. Okay, so we're gonna evaluate these without a calculator. This phrase is a math teacher's favorite phrase, without a calculator. Have you noticed? Yeah, okay, let's do this. So we're gonna piggyback on what Owen was saying earlier. When you have a negative exponent, it should be moved, it should be made into a reciprocal, right? So this is gonna be 1 over 49 to the half, which is the same as 1 over the square root of 49, which is 1 over 7. Okay? So remember, this is exactly what we did over here. Okay? Next one. So take a look at this one. I have the 5th root of 32. Now, look, don't write this yet. 32 squared. Now, I don't know about you, but I don't want to square the 32 and then have to deal with that. So, in a case like this, I will just put the 2 out here. So now, look, I have to do the 5th root of 32. So let's review this again, right? 32 is 2 and 16, 2 and 8, 2 and 4, 2 and 2. So how many 2's? 5. This says group them by 5 and you can take them out. So all these come out as a single 2 squared 4. Okay? All right. Next one. How would we rewrite this? Which root? Yeah, Ben.
2 over 8.
Huh?
Like the way you did the first one.
It would be cube root of 8 squared. Cube root of 8 is what these days? 2 again. Squared. Huh?
You don't need to put the 2 outside. You can get 1.
Huh? It's up to you. If you did like 64 and then cube root of 64, you could get 4. See how you're already like thinking you can do it both ways. Yeah, absolutely. So next one, now I have a negative exponent again, so I got to take the reciprocal. So it's going to be 25 over 1 to the power of positive 3 over 2. Now, write it as a root. This is the square root of 25 cubed. No, only when you take the reciprocal, you only take the reciprocal of the base, and then it gets rid of the negative exponent. Okay, this is a negative exponent. You have to take the reciprocal of the base and you make that positive. That's the only change you make. Okay, so this will be 5 cubed 125. Okay, guys, please, if you have questions, raise your hand so I don't stop mid-sentence, okay? Yeah. Oh. Okay. Any questions? Okay, so how do we simplify expressions then? How do you know you've simplified enough? Here we go. No negative exponents. This is never gonna change. Whether you're in algebra, calculus, or beyond, this is never gonna change. Never any negative exponents, okay? And then you have to make sure that there are no exponents that are not positive integers in the denominator. Okay? You have to make sure that you don't have a complex fraction. You have to make sure that the index is the least number possible. Okay, so basically, let's do one and we can take a look. Okay, so look at what I have here. When I have when I'm multiplying 2 powers, what do I do to the exponents? You add them. So this will be y 5 over 7. Okay? Now, always rewrite it as, always see if this is simplified enough. So basically, when you have a rational exponent like this, you have to make sure that the numerator is a smaller number. Okay? Because look, if you rewrite it like this as a root, you see how like this can't be simplified anymore? There aren't enough to take it out. This is because the numerator is less. If the numerator was a greater number, then you would have had to simplify further. Okay? All right. So this is it. This is fine. Yeah, this is the final answer. Huh? No, you don't have to write it in a root form because writing it in root form is not more simplified. It's just another way of writing it. Okay, next. This is going to be 1 over x to the 2 over 3. Okay? But now, this is a denominator that needs to be rationalized. Okay? So, to get rid of this, what you have to do, so take a look at this second one. You can't have any exponents that are not integers in the denominator. Is this exponent an integer? No, so you have to make it an integer. How do you make it an integer? You have to multiply x to the power of, subtract these two, what do you get? What's the difference? 1 over 3. So, and then x to the power of 1 over 3. So what you have now on the bottom is x to the power of 1, right? Because it's 3 over 3. And then in the numerator, x to the 1 over 3. Okay? That's the answer. Okay, next one. Okay, you have 6 root of 16, but 16 is made up of a whole bunch of 2's. So let's do this. This is the 6th root of 2 to the 4 over cube root of 2. Okay? Now, can we simplify that further? We actually can. Take a look at how we can rewrite that. 2 to the power of 4 over 6.
Please notice that's just rewriting.
Yes, but by rewriting it, we can go a little bit further, because how can we reduce that now? That'll be 2 to the power of what? 2/3. So this one, let's rewrite it as well, 2 to the power of 1/3. So what I have now is 2 to the 2/3.
Wait, how does that simplify to 2 times 1?
This doesn't simplify, we're just,
Oh, wait, that's
okay. So everybody okay with how we got this now? Okay, now this is 2 to the power of, let's subtract the exponents, 2 to the power of 1/3. Okay, confusing? Yeah. Okay, so wait. So here's what we do. First, look inside. Try to write it in terms of the most elemental base. Okay? You also have another clue because this is in terms of a 2, so it's best to make that in terms of a 2. Now, when it's in root form, convert it to exponent form. It's always easier. Usually you'll have something that cancels out. And once you have something that cancels out, you can zoom out and see the big picture and see if you can like add or subtract exponents. Okay, let's do another one. Okay. 6th root of all this. But look, is the 4 made up of different powers? What's the elemental base that the 4 is made of? 2 squared. And then you have x to the 4. So the idea is always, if you have a root form, convert it to exponential form. So this is going to be 2 to the power of what? 2 over 6. And then x to the power of what? 4 over 6. This over the denominator, exponent over the index, always. So now, this is going to be 2 to the power of what? And x to the power of 2/3. So you can write it like this, or you see how they both have a cube root? They both have a denominator of 3. It could be the cube root of 2x squared. Both of these are acceptable. Okay? Yeah.
How come for C when you got like it's 2 over 2/3 and 2 over 1? How come we don't divide the 2?
So if you had a to the power of 4 over a to the power of 2, what would you do? Right? Always go back to the basics, the basic form of how you've learned these. Okay, so next, we have again a conjugate situation. So, what's another way to think of y to the 1/2 in root form? It's root y minus 1, right? So what would the conjugate be?
Y plus
root y plus 1, but we're going to keep it in exponential form because we're, that's what we're doing. So I'm going to multiply top and bottom by y to the half plus 1. You see how it's the same as what we were doing yesterday, but in exponential form now. So now, let's go slow with this. First terms give you y to the what? Oh, it's controversy. It's y to the half times y to the half, y to the 1, because you add the exponents. I know you all want to say what 1/4. Okay. So now, that's the first terms. The outer terms, y to the half. The inner terms, y to the half. The last terms, 1. Here, we're going to square the first term, and that gives me y to the 1. Square the last term, minus in the middle, because it's a minus b, a plus b. So I have y plus, how much is this? 2y to the half plus 1 over y minus 1. Okay? That's the answer. Yeah. Yep. Okay, here. Oh, what do we have here? This is multiplication. So, okay, so look at this. You've got all these B's, you've got all these C's. Why don't we group them? Why don't we write like the B's, on one side and the C's on the other side? So I have a B on top, a B on the bottom. I'm just going to collect them. So I'm going to write it like this. Times C over C to the 1/2. I've literally done nothing. I've just rearranged them. No math. So now, B to the power of, what am I going to do to the exponents? Subtract, right? So it's going to be 3 minus 1/3. Okay, times C, 1 minus 1/2. So this is going to be B to the power of, how much?
2
Which is 8 over 3, right? Yeah? Times C to the 1/2. Okay, is it? What did we say about rational exponents before? In the very beginning, we said we always have to make sure that this is a proper fraction, right? That the numerator is always less. Is that the case here? The numerator is not less. So we're going to do what we were doing here. 8 divided by 3 is what? 2. Remainder, how many? 2. So this is going to be b squared cube root b squared times root c. Well, c to the half is root c.
Oh, yeah.
Can you have